and use long division and come up with a quotient and a remainder. You know this? All right. So we know how to do this, right? We can use long division to divide out a polynomial by a divisor and get a quotient, and we have a remainder of 58. All right. Now we're going to do some magic over here on the right-hand side, and I'm going to write down some numbers, and we're going to talk about it and see if there's a connection here. I'm going to write down the number 3. All right? And then I'm going to do a little box around right here. Anybody see a connection? This number 3 here, and this 3 over here? Oh, they're both 3s? Okay, good. All right. I'm going to write down some more numbers. I'm going to write down the number 1, the number 4, the number -5, and the number 5. Where did I get those from right there? Yes. They are the coefficients of my dividend, right? They are the coefficients of the dividend. Check it out. Everybody see that connection so far? Great. Okay, then what I'm going to do is I'm going to skip a line and draw a line. I'm going to skip a line and draw a line. And I am going to just bring this one straight down and put it right there. Easy enough, right? And instead of subtracting, I'm going to add. So here's what I'm going to do. I'm going to take this 1, all right, and I'm going to multiply it by my 3. I'm going to put my answer right there. So what is 3 times 1? 3, good. And I'm going to add vertically. What do you get when you add 4 and 3 together? You get a 7. Good. I'm going to repeat this process. I'm going to take 7. I'm going to multiply it by a 3. I'm going to put the answer right there. What's 7 times 3? 21. Good. And I'm going to add these up. -5 and 21. How much is that? 16. Good. I'm going to repeat the process. Take 16. I'm going to multiply it by a 3 and put the answer right over there. What is 16 times 3? 48. Very good. And I'm going to add this up, and what do I get? 53. All right. Anybody notice anything? Yeah, check this out. There's a 53 there. There's a 53 there. Huh. And then what about these numbers here? A 1, a 7, a 16. Anybody see a 1, a 7, and a 16 on the left-hand side? Oh, dude, a 1, a 7, and a 16. Oh, they kind of go away with red and red, huh? That's not good. Okay? So what's going on here? Anybody see what's going on? Yes. So the process on the right-hand side is called synthetic division, but it's important to understand what these things are. So I always put a box around on the very last one. This is my remainder. Okay? This is my constant. This is my x term, and this is my x squared term. Now I'm sort of working backwards. You notice that each one builds up. Remainder, constant, x, and then x squared. Well, how do you know that it's going to be an x squared? How do you know that? Exactly, because we started with an x cubed. We divided by an x to the first, right? And if you think about x cubed over x to the first, that gives us an x squared term, right? So if we're just looking at those first coefficients, it'll always be 1 less than the dividend, all right? The process on the right is what's known as synthetic division, and that's plus or a minus c. All right, so we've seen synthetic division before, and maybe advanced algebra 2. But there are some limitations to synthetic division that I want to bring up. One, it only works when you're dividing by x plus or minus c. So you have to have this sort of singular factor here. An example would be like, x minus 5. We could do synthetic division with that. We could do synthetic division with like x plus 2, no problem. And you take the opposite sign of c. And I'm talking about that c right there. So you have to keep these two things in mind when using synthetic division. All right? It can only be used when you're dividing by a binomial with a degree of 1. And you take the opposite of c. So let's do a little example to solidify what we're talking about. If I want to do 5x cubed plus 6x plus 8, I want to divide this all by x plus 2. All right, first of all, am I even allowed to use synthetic division? How do you know? Because I'm dividing by a binomial with a degree of 1. No problem. So I'm going to take the opposite of c. In this case, the value of c is 2, so I'm going to take the value of -2. And I'm going to set up my synthetic division with a 5, because that's my coefficient. But I don't have an x squared term. What do? Put a 0. Good. Then what? A 6, and then what? An 8. Very good. Okay, good. Skip a line, draw a line. Bring the 5 down, and we're going to add. All right, so 5 times negative 2, what do you have? Negative 10. So that goes here. Negative 10 and 0, what does that give us? Negative 10. Negative 10 times the negative 2? 20. 6 and 20? 26, good. 26 times 2. Negative 52. Negative 52 plus 8? Negative 40. Negative 44. Good. So this is my remainder. This is my constant. This is my x, and this is my x squared term. All right. What do you think so far? Is that pretty good? So it turns out that I can say that this is equal to 5x squared minus 10x plus 26 minus 44 over x plus 2. Or I could have said this, 5x squared minus 10x plus 26 with a remainder of negative 44. Either one of those two things is totally acceptable, right? 2x minus 3 with a remainder of 0. Do you guys get that? X squared minus 2x minus 3 remainder 0, yes? No, Rachel did not get that. Okay, what'd you do? Can you figure out what you did wrong really quickly? Oh, yeah. Okay. Now that we got synthetic division kind of under our hats here. Okay, there you go. We have 2 theorems that we're going to talk about today, and the first one is called the factor theorem. All right, so we're talking about factors here. The factor theorem is going to tell us something about factors. What are factors again? Yeah, okay. Very good. So, like, what are the factors of 6? Yeah. What are the factor, like, when we take a quadratic and we factor it, we're creating 2 binomials, right? Those are factors, right? So, if I give you some funky polynomial here, 2x to the third minus 3x squared minus 11x plus 6, and I try to talk about this function, one thing that we could talk about are the factors of this function. And so I want to then take this and divide this by an x minus 3 per se. All right? So this is going to give me some information about this function. So we are set up to use the tool of synthetic division to investigate about this particular function. So let's go ahead and set that up. So I'm going to have 3, and I'm going to have a 2, and then a negative 3, and then a negative 11, and then a 6. All right? And the same sort of process here. Bring a 2 down, and we're going to add. Okay, so if I move through this pretty quickly now that I got synthetic division down, 2 times 3 is 6. Add this up. I'm getting 3. Multiply, I get 9. I get negative 2. I'm getting negative 6, and I'm getting 0. All right. This right here, this means something. The fact that my remainder equals 0, it tells me something special. Okay? What it tells me is 2 things. Number 1, it tells me that x minus 3 is a factor of f of x, where f of x is this thing over here. And the second thing it tells me, number 2, that f of 3 is equal to 0. Okay, I need you guys to interpret this part right here. What do you think that means, f of 3 equals 0? What does that mean? Yeah. Very good. When I actually plug in a 3 to this, 2 times 3 cubed minus 3 times 3 squared minus 11 times 3 plus 6, I'm guaranteed to get 0. That's what it tells me. It tells me that f of 3 is equal to 0. But we can also take this a little bit further if we investigate something on the calculator. So I need you guys to have your calculators out. And I want to plug this function into my calculator, and I want to show you some cool things with it. Okay? So it should look like this. Everybody got in the calculator? Okay, so once this is entered into our calculator, I want to show you a few things about this. Okay? First, I'm going to hit zoom 6 so we're all looking at the same picture. All right? It's right here on the screen. 2x cubed minus 3x squared, right there in the red. Okay? Does anybody notice anything about when x is equal to 3? When x is equal to 3, what do you see? It's on the x-axis. So that also tells us if f of 3 is equal to 0, then that means that 3 is an x-intercept. Oh, so we can take that a little step further. Now, there are two other x-intercepts. Do you see them? Yeah. Okay, there's two other ones there. Check this out. If I go second calculate, I can see that there is one of my options is a value. If I hit value, you can ask the calculator for specific values of x. So check it out. If I plug in a 3, it's going to spit back to me a 0. We already knew that one.
Wait, how did you get to the
Second trace. Okay. Now, watch this. Check out, there's two other ones. There's one here and there's one over here. What do you think those are? 0.5 and negative 2. So let's see here. Second, calculate, value. Let's plug in 0.5. Check it out. Oh gosh, another 0. So that means that x minus 0.5 is a what? Is a factor. Very good. Is there another 0 that you see? What? Negative 2. Let's see if that works. So plug in second trace. Give me a value. Negative 2. Plug it in. Bam. Yep. I get a 0 out of that too. So negative 2 is a 0. That means that x plus 2 is a what? As a factor. That's what the factor theorem tells us. What do you guys think so far? Pretty good? Minus 2. That's the question. So, for you right now to discuss, is x plus 1, is this a factor of the polynomial function f of x equals 15x cubed plus 14x squared minus 3x minus... How can this be true? Okay, the remainder theorem, the last theorem of our day we're talking about, it says this. It's an if-then. If f of x is divided by x minus c, then the remainder is simply f of c. Crazy. These two c's mean the same thing right here. All right? So let me explore this with you. So check it out. If I have x to the third minus 4x squared plus 5x plus 3, and I want to divide this by x minus 2. Okay? First thing I'm going to do is I'm going to just go ahead and use synthetic division, the good old synthetic division way. So I'm going to go 2. I'm going to go 1, negative 4, 5, and 3. Skip a line, draw a line. Add. Bring the 1 down. I'm getting a 2 here. This looks like negative 2. This is negative 4. That's a 1. That's 2. That's a 5. So what is my remainder? Okay. We all agree through synthetic division that when I take x cubed minus 4x squared plus 5x plus 3 divided by x minus 2, I get a remainder of 5, right? This is my remainder. Okay. And is x minus 2 a factor of that function? Is x minus 2 a factor of the function, you guys? No. No, why not, Bailey? Because the remainder is 5? Not 0. Okay, good. So is 2 a 0 to my polynomial? No, it is not. Okay, now watch this. According to the factor theorem, which is the factor theorem it says up here, it says that I could easily get this by just evaluating f of 2. So check this out. If I take 2 cubed minus 4 times 2 squared plus 5 times 2 plus 3, guess what I'm going to get? Holy cow, I get 5. That is ridiculous. Are you seeing the connection here? So I want you to connect these two numbers, and I want you to connect these two numbers. Yes, the one on the right. No, the one on the right is using the remainder theorem. This will tell me the remainder theorem is simply f of 2, which is 5. But we figured that out using synthetic division. But now we have a theorem that will tell us what it will be without using synthetic division. That's the crazy part. You dig it? Okay, so let me ask you this then. If I gave you this, 2x cubed minus 11x squared plus 7x minus 5, and I said divide that by x minus 4, what's the remainder going to be? 4. Yes, the remainder is simply going to be f of 4.